Hello math people, in this video we are going to talk about graphing quadratic function in the standard form. That equation can be written in the form y equals a x minus 8 squared plus k. Okay. The first step is to determine if parabola opens up or down. This depends on the sign of a. If a is greater than 0 means it's positive, parabola opens up. If a is less than 0 means it's negative, parabola opens down. The next step is to find the vertex hk. The vertex hk is obvious from the equation. Just keep in mind whatever is inside the parentheses, you're going to take the opposite sign of it. Okay, next step is to find the x-intercept by plugging y equal to 0 and solve for x. And then we'll find the y-intercept by plugging x equal to 0 and solve for y. Finally, graph these points and use the symmetry and label all points an equation of axis of symmetry. One thing it's important to remember, a vertical parabola will always have one y-intercept. It may have 0, 1, or 2 x-intercepts. So that means it's going to touch the y-axis all the times, only at one point. It may touch the x-axis at none points. It may never touch the x-axis. It may touch the x-axis at 1 point, or it might touch the x-axis at 2 points. Okay. Vertex is the max or min point of the parabola. So if your parabola opens up, the vertex is the minimum point, the lowest possible point. If your parabola opens down, vertex is the maximum possible point. Okay. Again, if a is greater than 0, parabola opens up. A is less than 0, a is negative, parabola opens down. There's another way of graphing parabola. You can skip steps 3 and 5 and make a table of x values like we did in the other form, in the general form of quadratic equation. Okay, that's in the other video. So look at that video. That method can also be used here. Once you know the vertex, you can make a table of x values around the vertex and plot at least 5 points and get your parabola. Here's first example we're going to graph. So first step is to identify the vertex. My first step is I'm going to be looking for where is the vertex. So vertex is, actually before that, let's think about if parabola opens up or down. Well, I do have a positive 1 here. So a is greater than 0. That means parabola opens up. Okay, it's an upward opening parabola. Second, the vertex is going to be 2 and 5. Okay, so this is my x-axis, y-axis. The vertex is 2 and 5. X is 2, y is 1, 2, 3, 4, 5. All right, parabola opens up. Vertex is 2 and 5. I already know it's not going to have, it is not going to have no x-intercept. How do I know that? Because I know parabola is opening up. It's never going to come down and touch the x-axis. Next thing I'm looking for is I'm going to be finding the y-intercept. To find the y-intercept, we plug x equal to 0. So this is same thing as y equals x minus 2 squared plus 5. Y equals, to find the y-intercept, let's plug x equal to 0. So we get 0 minus 2 squared plus 5, which is 2 squared plus 5, which is 9. So y-intercept is 9. Okay, y-intercept comes out to be 0, 9. So to get the y-intercept, we plug x equal to 0. So x is 0, y is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now what I'm going to do is I'm going to use the symmetry from here. I know this is the line exactly in the middle. Axis of symmetry passes through my parabola. So if point 0, 9 is on the parabola, then I will have a point over here that's going to be also a point on the parabola. And coordinates of that point, the x value is going to change, but the y value still be same. Well, x equals 2 is exactly in the middle. So x equals 0. If I use the symmetry, this will be x equals 4. So 4, 9 will be the another point. And now it's time to connect the dots. And here's our parabola opening up for this equation. Right, next example of graphing quadratic function, y equals negative 2, x plus 1 squared minus 4. All right, the very first step, I know that this parabola opens down. Okay, this parabola opens down because I have a negative a. Okay, step is to find the vertex. Go ahead and find the vertex. The vertex is going to be -1 and -4. Remember, we talked about take opposite of everything inside the parentheses. Take the opposite sign. So x is -1, y is -4. That's going to be here. That's my vertex. And parabola opens down. So again, there's no x-intercept because I already know that parabola opens down. And it's never going to go up and touch the x-axis. So there's no x-intercept, and I'm not going to waste my time in finding the x-intercept. Even if I try to find the x-intercepts, see what's going to happen. I'm going to get something imaginary. Okay, if somebody doesn't realize that and they go ahead and try to find the x-intercept, you can go ahead and start by plugging 0 equals -2x plus 1 squared minus 4. 4 goes to other side, -2x plus 1 squared, which turns out to be -2 is x plus 1 squared. Take the square root on both sides, plus minus √2 I equals x plus 1. X is -1 plus minus I √2. And that is imaginary, right? That's not a real number. So there's no x-intercept. Keep in mind. And you don't need to do the work to find them when you already know there's no x-intercept. You could save yourself time. Or if you accidentally went ahead and tried to find the x-intercept, you wouldn't find any because you would get something imaginary. Okay, let's go ahead and find the y-intercept. How do we find the y-intercept? We plug x equal to 0 in the given equation. Y equals -2, 0 plus 1 squared minus 4. That turns out to be -2. That turns out to be -6. Okay, so the y-intercept turns out to be -6. That's where it touches the y-axis. Using symmetry, I can get another point. And there's my parabola opening down. It's important to label, think about domain, range, and label the axis of symmetry. What's going to be the domain for this parabola? Domain would be all real numbers. How about the range? What y values does it take? It only takes -infinity to -4, actually, not -6. -infinity to -4. What is the axis of symmetry? Axis of symmetry is always the x coordinate of the vertex. So x equal to -1. This is the straight line that will be passing through your parabola exactly in the middle. That's my axis of symmetry. Okay, that would be equation of this line would be x equals -1. Right, let's look at another example. Again, this one, first I know that this parabola opens up. I already know that because my a is positive. Second, I'm going to look for my vertex. The vertex would be -3 and -2. Remember to take the opposite sign of whatever is inside the parentheses. Okay, here, that's where we got the vertex from. Now it is time. Let's go ahead and plot the vertex and just think about how the graph is going to look like. -3, -2. X is -3, y is -2. That's where my vertex is, okay? Now, if you look carefully, I already know that this parabola opens up, so I can tell it's going to touch the x-axis at 2 points because it has to go up. It's going to be touching the x-axis at 2 points. Let's go ahead and find the x-intercept. To find the x-intercept, we plug y equal to 0. So let's go ahead and plug y equal to 0. So that turns out to be 0 equals 2x plus 3 squared minus 2. Go ahead and solve this equation. 2 equal, and that turns out to be 2 divided by 2. 1 is equal to x plus 3 squared. Go ahead and take square root on both sides. That would be 1 plus minus 1 equals x plus 3. X equals -3 plus minus 1. So x equals -3 minus 1, -3 plus 1. There's my two x-intercepts. That's -4 and -2. Okay, -2 and -4 are my two x-intercepts. Well, that doesn't show me a good picture of the parabola. Now I'm going to find the y-intercept. How do we find the y-intercept? To find the y-intercept, plug x equal to 0 in the given equation. y equals 2, 0 plus 3 squared minus 2, which is 2 times 3 squared minus 2. 3 squared is 9, 9 times 2 is 18, 18 take away 2 is 16. So somewhere here I'm just going to mark that that's my y-intercept, 16. Now I can use a symmetry and get another point. So in the middle I have -3, -2. Okay, and if I use the symmetry and I try to get another point, so this point has the coordinates 0, 16. The y will be still 16 because I'm just going, horizontal, but the x would be, x equals -3 is exactly in the middle. So this is going to be -6. All right. Yep, that's going to be about here. Right here. All right, now it's time to connect the dots, plot the points, and it has to touch. Let's fix it. It has to touch the x-axis at this point, y-axis at that point, at 16. All right, so there's my parabola. Now let's go ahead and think about the domain here. Domain for a vertical parabola is always all real numbers. And range for a vertical parabola is going to be the y values, and it only takes the y values -2 and above. So use the parenthesis bracket around -2, not the parentheses. -2 to infinity. These are all the values it takes. And axis of symmetry, here in this case, the axis of symmetry is going to be the line passing through the middle, which is going to be line passing through the middle of my parabola, which is going to be, this is the line. If I fold along this line, I will have two congruent parts. X equals -3 is my axis of symmetry, and that's all in here. Okay, so I want to talk a little bit about transformations. How can we look at graphing a parabola using transformations? Okay, so let me add another page here. If you have equation y is equal to ax minus 8 squared plus k, now if you know the graph of y equals x squared, we can transform that graph to get this new graph. The k is plus k, moves the graph k units up, and minus k moves the graph k units down. Okay, and this h inside, if it's negative h, it moves the graph to right, and plus h moves the graph to left. Let's see an example. Y is equal to x minus 3 plus 5. We already know y equals x squared is a graph that looks like this. I'm just using a rough sketch. How are we going to be able to move this graph? Well, it tells me that I need to move my graph 5 units up. So I can just pick 3 points on my parabola, or 5 points on my original parabola, and move every point 5 units up and 3 units to the right. Okay, because the vertex is going to be 3 and 5. It's going to be something like this. Okay, every point gets moved 3 units to the right and 5 units up, and that's how my parabola is going to look like. Now, another thing I want to add is you can always toggle between the forms. So if you don't like this form and you feel more comfortable graphing y equals ax squared plus bx plus c, find the vertex by x coordinate of vertex by doing x equals -b over 2a, and then plug that x coordinate back in to find the y coordinate of vertex. And then from there you want to make a table. You can go ahead and do that, because you can open up this bag. X minus 5 squared would be x squared minus 10x plus 25 plus 1. y equals 4x squared minus 40x plus 100 plus 1, 4x squared minus 40x plus 101. You can go ahead and graph this using that technique. Although this is not very pretty equation, it would work out just fine. The next thing I want to talk about, if you have an equation in this form, in the general form, you can change it to the standard form by completing the square. So if you want to write it in the form y equals a x minus h squared plus k, you can do that as well. Right now, it's in ax squared plus bx plus c form. You can toggle between